propulsion. But
Hey, we're just talking to ourselves because I don't think anybody's joining us today.
that's okay.
Jack might.
Yeah, we're
Federico might.
You know what? Hold on, let me double check.
I bet your parents, your mom is. Hey, go lie down. Go lie down. You weren't allowed to come in here to get in my face.
My parents are driving up to us right now. Katie and Adam have a D&D campaign there. So yeah, they have a life. So they're enjoying their Sunday.
life doesn't center around us.
Yeah, so if anybody's joining us, great. Otherwise, we're here just hanging out.
I look like a fat hobbit just sitting
Why
there.
are you? Don't be mean to yourself like that.
Oh, it's just true.
That.
Nobody's listening.
I mean, first of all, calling yourself a fat hobbit means you like Sam, and Sam's the best.
He's
so
the hero.
ultimately, that's a compliment.
No, I'm proud feet. I'm that fat hobbit.
Wasn't that a woman? Is that a woman hobbit or is that a guy hobbit?
I think it's a guy.
You know,
It was like a grandma
Some say
hobbit.
women hobbits don't really exist. That hobbits just spring out of the ground.
Couch patch hobbits.
That's funny.
Are we just trying to get the Lord of the Rings stuff out of the way early that we're not just constantly...
I haven't been on the show in a while, so I got to get the references out.
Yeah, that's true. I know.
Was it since Korea? Since before Korea?
I think so. It was... God, I can't even remember.
There was a high in the sky.
It was many moons ago.
Oh, no. I think I was like super jet lagged, so I just showed up and I said like 3 words the whole time.
Yeah. It was one of those last minute where you were like, yeah, I'm joining us. And I was like, don't you want to sleep?
All right. Well, since nobody else is putting in anything in chat.
Do you want a countdown?
He doesn't like a countdown.
No, you can...
I don't know why I thought it was a lizard show.
No.
It's a physics show.
This is a Mike-led show.
Why?
Because I do the high in the skies. Hold on. Before you start, tell me when you're ready, and then I'll give a little. So it's easier for me to find. When I'm editing out all this preamble bullshit.
Well, we need a.
Yeah.
Is it a? No, the clapper's like a clap on.
Oh no!
Clap off.
It'd be great if I programmed Google.
Yeah, but no, we need those things.
No, an actual like director thingy.
Yeah, it's
That'd
like
be cool.
What is it called? Oh, it's like
a name.
It's like I know what it is, but I just can't. All right, we got to take this time in the show to look it up because otherwise it's going to drive us all crazy.
Director clapboard.
That's what it is.
It's called a clapboard.
It's a clapboard.
Clapboard.
Yeah.
Oh.
Movie clapper thing is one of the. Oh, I'm getting one.
Oh, it is.
I'm getting one.
Are you getting one? Okay. Do I want one? It's $8.
It's not bad.
Add to cart.
Yes.
Do you write on it with chalk?
Huh?
So do you write on it with chalk?
It comes with a pen.
I have a good D&D session.
Bye.
Okay.
We're in a rare hangover form already.
I know
nobody's here, so
we're just
All right,
putzing around.
true.
We're putzing around. All right, are you ready?
We got dogs
All
coming.
Brandy, give me a count in.
A count in? Hell yeah. And in 5, 4.
Hey everybody, welcome to Cosmos with Cosmos. As always, I'm Mike.
I'm Liz.
And I'm Brandon.
Hey!
Yay!
Hey!
The gang is
Guess
back
who's here?
together.
Woo! Guess what we're talking about today?
I don't
The
know.
3 body problem.
Hey, topical.
Oh, it's like us.
Yes.
Exactly.
Yes. Now, just to say, there will not be any TV show spoilers. We're going
Right.
to
We're going to try to
We're going to
minimize
try
it.
to minimize any TV show spoilers
Or book
or
spoilers.
really book spoilers as well. And it's just not about the media that
Right.
has been re-released, but the science and the physics.
Yeah, there's we're going to talk about
It's
a few things
educational,
that show
people.
up. We're going to talk about a few things that show up.
Yes.
And just really the physics of it.
Yes.
And not so much how it's used as plot points and devices and things like that.
Yes, but we recommend you check it out. The movie or the TV show or the book.
I'm reading the book now. It's a lot of fun.
Yeah.
It's
I'm interested in reading the book.
Quick read. Quick and easy read. It even has a physics lessons on pull. How hitting a
the
ball
game
works.
of pool.
The game of
Okay,
pool.
the game
Oh,
of
that makes
pool.
sense because we're going to talk about chaos theory later on. And Malcolm from Jurassic Park has a great quote about chaos theory using pool as an example, which I actually have the quote up right
Hey.
now.
Oh, yay. Okay, I'm excited. I'm
All
excited.
right. Brandon,
What's up?
what you drinking, man?
Ooh, so I am drinking roads where we're going. We don't need roads.
Yes.
We'll get into that later on. But it's basically a maple syrup old fashioned.
Oh, yes.
All right. I guess he's got time before he's got.
Yeah.
Oh, and then for second drink, I have Tempranillo.
Ah.
Because I made some whiskey sours, not whiskey sour, New York sour earlier. Not today. And then I got a whole thing of wine, so I got to drink wine.
Nice.
Oh no.
I've
Oh.
yeah.
By the way, you had a nice float on your New York sour.
I think I put a little too much wine in it, which is fine because I like a lot of wine in it. But
No, it's fine. It's fine.
I've recently been into this red wine called Three Fingered Jack.
Oh, it's
red
good.
wine.
I like it. Is it Cab? Is it Cabernet Sauvignon?
Yeah.
I think so. But it's
Yeah.
really good. I think I'll
Excellent.
have that with dinner tonight.
What you drinking?
Oh, I am drinking the Three Liquor Problem.
Nice.
Looks
What's
like
it?
white wine.
It
Is
does
that white
look like
wine?
it does look like white wine, but
Or
it's
like gasoline.
not. It
Or gasoline.
well,
Wow.
it tastes much better. It has peach
Schnapps, peach
schnapps.
butterscotch schnapps, and cinnamon whiskey.
Yeah, so it's
What?
very sweet.
My favorite thing, I'm not sure if you know this, Liz, but you have a face you make when you don't know what's in the drink and you look at Mike. It's a very distinct face.
Is it this
it's not
face?
that. It's not that face.
Oh,
It's a different face. You do it subconsciously.
okay.
And I'm looking down and I can see.
You could just sense when
I
I'm
can
like,
sense
please
it.
give me the
I can
answers.
sense it. Yes.
It's like
Yeah.
when I need you to tip something, I'm like,
Basically, it's 2-1-1, so twice peach schnapps, and then cinnamon whiskey and butterscotch
nice.
schnapps are each one each.
it's sweet. And then for my second drink is just a good old fashioned Black Butte Porter from
But in
good
the
old
coolest
Oregon.
koozie.
But in my astronaut
'Cause-
koozie.
We ain't going nowhere.
Nope.
All right, so this little blue drink.
So much fun.
Ooh.
So pretty. So vibrant.
That is pretty. It's like Neptune.
Yes.
Yes.
I am calling it the Trisolarian
Ooh, Trisolarian.
from the book.
Okay.
And
Try 3. Look at them go.
yes, and so, but it has 4 things in it.
Oh, Trisolarian. Try 3 soul suns.
There you
Ah!
go. There you go.
And it has, in this case, you can do it 2 ways.
Oh,
You can make it
okay.
2 ways. This has raspberry vodka.
Oh, you
blue
did the
curacao.
raspberry
Yeah,
vodka.
I bought that raspberry vodka just for this one drink.
Uh-huh.
I wanted to test it, and I have not tested it yet. But raspberry vodka, blue curacao,
Mm-hmm.
lime juice,
Ow.
and a little simple syrup.
Nice.
But if you want to make it a different way, you can do white rum. Don't do dark rum, gold rum,
no,
Jamaican
no.
rum.
The white rum I tasted and it was pretty good.
Yeah, you want to use white rum because you want the blue color.
And regular vodka was pretty good.
Yeah.
Go, taste it. Let's see. How is
Oh
it?
yeah, I can get behind that.
Yeah.
Excellent.
Yeah. So, this is a
try.
drink that
Ooh.
that I
Ooh. It's
we
like
watched.
it's like blue raspberry flavor.
We watched Star Trek: The Undiscovered Country yesterday.
Nice.
Yes.
It is actually it's my favorite of the original movies.
Really?
Yes, I love Undiscovered Country. And so we watched it, and this is a take on Romulan Ale. So cheers, everybody.
I have a little bit of Romulan ale still left.
Oh, from the Romulan ale that you bought.
Yeah.
And my second drink is tea, vodka with peach syrup in it.
You can call that Klingon blood ale.
Yeah.
Yeah. Actually, we do have a drink called Captain's Blood, which really comes out kind of as a pink color.
It does.
which
So
is
it could be Klingon blood ale.
Klingon Blood.
Okay.
All right, so follow us on all the things on Twitter, because I will not use the other name. Drinking Cosmos on Twitter,
So rebellious.
Cosmos, and everything else. Rate us and follow us and rate us on wherever you get your podcast. And don't forget to join us later for The Hangover.
Yeah.
All right. And as always, you want to check out Wildixia on Etsy. That is Wildixia. Get all kinds of really cool artwork. Friend of the pod, Ron Proctor. You can catch his stuff on the Mr. Proctor Show. And of course, what's that?
.com?
.com.
Oh, yes. .com. Sorry. I'm like, I did give it a... all right. So, and if you're in the southwestern corner of Iowa, or I guess the northeastern corner of Nebraska, or something, I'm not sure how to say. Anyway,
what's happening?
If you're in the Council Bluffs area of Iowa, check out Rolling Bluffs Planetarium, Jack's Planetarium. You can check out rollingbluffsplanetarium.com for more information about what they got.
Yay!
Also, join us every other Wednesday for The Shot.
I am overdue on making some of those.
Yeah,
yes,
you are.
You
Yeah, you are. And we need some coming up here.
Yeah, are we doing it next weekend?
Yeah, next weekend we have to
I'll do like 3 in a row, just me.
There you go.
Yeah, so if you like a little, what do you call it? Bite size?
Just shots of astronomy. If you like quick shots, quick tidbits, quick things, short form media.
It's great. We have all kinds of topics. We've done like 50 of them.
Yeah.
That's so much fun.
Yeah, we got one coming out on eclipse. One's out on eclipses.
Yeah. Oh, and tomorrow.
Eclipse.
If you're watching this like right now, which I don't think anybody is, the eclipse is here tomorrow here in the States. I
am promoting the eclipse episode of The Shot tomorrow as well on social media.
All right, rules. As always, the puppy barks. Go ahead and take a drink. Star Wars or Lord of the Rings references as well.
Any special rules today?
If Leia gets in our face, because she will get up.
Both dogs are in the room right now with us. They're just...
who let the dogs in?
Yeah. Well, otherwise they whine and then they get all... Jackie, I mean, picture Jackie all sad, which is
I
how
was going with
a
bad reference to the Baja Men, but sure.
Yeah.
I know you were.
Boys? I've seen them live.
Baja Men.
That's a fun story when I saw them live.
I thought it was
Why
Baja
did you
Men.
see them live?
Anyway.
They were at Epcot.
Oh, it's Baja Men, yeah.
Oh, I thought, okay.
No, he said Baja Boys.
Right.
But I like alliteration. Anyway.
Baja Boys.
Physics.
Let's get started. Let's jump right into it. You guys don't need to be doing all this other stuff.
Body problem.
All right, we're going to begin with the 3-body problem because that is exactly the name of the book and show. And so we'll just start with it.
Sounds like when it sounds like when a threesome goes wrong.
I mean, yes. I guess the aftermath.
Okay.
Oh.
Anyway, the 3-body problem in physics, not in sex, is famous for being unsolvable, but it has been solved.
Wait, it has been solved?
Yes, it has.
Oh, I didn't know it was solved.
Yeah.
I thought it was a forever problem.
Well, it is, and you'll find out.
Mystery.
You'll kind of find out how it is a problem, but but it did in the. Well, you'll find out.
Okay, so when you say solved, it's more like it's been solved.
Right, but some of its solutions, some of its solving are useful, but most aren't. And there are going to be some solutions that we all know and love.
Okay.
And that we've heard of and we've talked about here on the podcast and all that kind of stuff. So let's start in the beginning.
Oh,
yes, right.
Yes.
So,
what is the 3-body problem?
The beginning. Diddle-doo, diddle-doo, diddle-doo.
Very good. So we do have to go back in time, 1687, to one Sir Isaac Newton.
Ah, the Newts.
Oh, who's that?
Yes, and from that, we have the two-body problem.
She turned him into a Newt and he didn't get better.
What?
She turned him into a Newt and he didn't get better.
I got better.
We are in the rare form already.
Ah, yes.
Anyway, in 1687, Principia was unleashed upon the world.
Oh.
And within it, you have his equations of motion, you have the laws of gravity, and all that kind of stuff. And if you put all that together and you do some stuff, some calculus and some math,
which he also invented.
Which he did invent.
He literally pulled out of his ass.
You actually can have the 2-body problem, which is easy peasy to solve. It's really easy to solve. And it gives you a simple and exactly solvable solution, which in physics and math we call an analytic expression.
Analytic expression.
Yes.
So, tell it to my therapist, see how it goes.
I'm going to be so lost.
So basically, what it did, Principia, what it did was it transformed an erratic and chaotic universe into one of predictability.
Oh, an orderly.
Logical,
Vulcan universe.
So the two-body system, it has equations that basically describe the path the body follows around whatever the other thing is.
Okay.
The star, planet, you know, that kind of
central
thing. And you've heard of them, ellipses,
yes,
parabolas,
hyperbole.
These are all conic sections. So if you have a cone and you take a slice out of it, you can get all three of these.
Slice.
Yes.
Okay.
So they're called conic sections.
This is a lot of high-level math that I never got to.
High-level math cones.
High-level math cones, yes.
Well, you know what a cone looks like, right?
Yes.
Yeah, right, never mind.
I got that far in my visualization. And it was a road cone, if anybody wants to know what I visualize as cone.
Okay. Only one case has a simple solution. Only one case.
Okay.
Excellent.
And that is when you have two bodies orbit each other without any other gravitational influences from the rest of the universe.
So
can that
impossible.
happen?
No.
No, because every gravity's everywhere is affecting every
Gravity
other
is.
gravity's everywhere.
Unless it's like Leia going around Liz, then nothing will impact that.
Yeah.
No, exactly. Okay, so we already know that the two-body solution, easy peasy to solve, but it's just not really what is seen in the universe.
It's not elegant.
No, it is elegant.
Oh, okay.
It is elegant.
Okay.
It's an elegant solution. However, it doesn't perfectly describe how the universe.
Yeah, because the universe is wild and wacky. It seems like we can explain one thing, but then we need to like do new math to just explain one other thing, just because it's like Mercury orbit versus you know the rest of the planet's orbits kind of thing. You know, you need two different types of physics.
Right. And so once we came up with like I'm involved.
Yes. Okay. You're a human species, so
yes, once people that were smart came up with a solution for the two-body problem, they started to look for three or more. They wanted to add.
Oh, they wanted to add more problems
yes.
because until you get to 99 problems.
Right. So astronomers and mathematicians started looking for a solution for three or more bodies. It became an obsession.
I love when scientists get obsessed with one thing.
Yes,
I love those stories.
It really did become an obsession with a lot of people.
Writing equations all over the walls.
We quickly found out that chaos rules when you do this, and we also found out that it seemed impossible to solve. So, in fact, so much so that in the late 1800s, Ernest Bruns and Henri Poincaré,
sure,
in French.
You did Henri, right?
Henri Poincaré said that no general analytic solution exists.
Well, that's that then.
So
now
said it can't be solved.
This is specifically 3 or 3 plus.
3 plus.
3 plus. So anything after 2 is like
anything after 2, and they said it can't be solved.
Okay, never.
The interesting thing is, we'll get to this later. Was 20 years later, somebody did come up with a solution, but it's impractical. But they did come up with a solution.
Is it a solution if it doesn't work?
The one that was 20 years later. All right, so there was a Finnish. I don't know if he was a mathematician or a physicist, but he used what is called a series in math, and it basically would need 10 to the 8 terms. So that is 10 million terms just to be able to do a simple or an average astrophysics calculation. So it is not. It's just not usable. You would need a computer to do it now. You couldn't write out all those terms on a piece of paper because it just wouldn't.
That's when you need the walls. That's when you need the walls.
Yeah, and so his name was Sundman, and Carl Sundman, and he used a power series, and it's 100 million terms for a simple celestial mechanics calculation. So it's not very useful.
We got computers, though. They can
but he did find a solution.
Okay. All right.
And so, but anyway, so yeah, I just think it's funny that, they say it can't be solved, and then 20 years later it kind of happens. But, so the question is why? Why is the 3-body problem... What'd you say?
I said, do we care? Why do we need Why do we need 3+ bodies?
Well...
I know most of star systems are binary plus star systems.
But in all seriousness, if you look at our solar system, you look at the sun, Jupiter, and Saturn, it's pretty much automatically a 3-body.
Oh, okay. I was going to say we got 8 bodies and Pluto's not one.
Yeah. So you do need it. It's very important to be able to make these calculations. For like a long time ago, you needed it for like celestial navigation, but also more importantly now we're launching all this shit everywhere, so you kind of need it for that as well.
Yes.
All right, so why is it so chaotic? So the evolution of a 3-body system is always dominated by chaotic dynamics. So what does that mean? That means that future states, where things are and how they're moving, is highly dependent upon small changes in initial conditions. So if you let's say you have a 3-body problem, so the sun, Jupiter, and Earth. If you move Jupiter just a little bit, it causes big implications for where the Earth will be, 100 million years from now.
Yes.
And so, in fact, in 2019, there was a solar system simulation done where they wanted to calculate where everything was going to be.
Let's fuck with the planets a little bit.
Yeah, everything was going to be in 5 billion years.
Yeah, fuck you, Venus.
Yeah. So they ran 2,000 simulations.
Okay.
Everything stayed the same except for one planet. And what they did was they changed Mercury's orbit by 1 millimeter.
What?
Was it a millimeter?
It was a millimeter from one simulation to the next. Remember, you're going over large time frames here. So
True.
1 millimeter changing Mercury's position 1 millimeter now isn't going to really change anything in our lifetime, but over 5 billion years it does. So in 1% of the simulations, Mercury hits the sun or Venus.
Oh, but then how's that fuck up the rest of us?
Well,
by that time the sun will swallow us anyway.
Well,
in one simulation,
I went like this.
Oh.
I went like this. I did the I did the
Sorry.
In one simulation, one of 2,000, the entire inner solar system was fucked up. It got destabilized. Shit went everywhere.
Everything's just like, until it eventually either flies. Well, no, it'd have to fall in the sun eventually, no? Or it would eventually stabilize?
Not necessarily. Because...
meanwhile, Jupiter's just like...
Usually...
What's going on, guys?
Usually...
Yeah, right?
So usually one of the bodies actually gets ejected.
Which one?
Well, probably the smaller mass object.
Is Mercury?
Maybe.
Goes flying?
Yeah, but it also could be us.
So, that'd be kind of fun.
Yeah, well.
Shot out of the solar system?
For a little bit until it gets real cold.
Real dark.
So... basically, it's a conservation of momentum kind of thing. Right. Conservation of energy.
Yeah.
So if you just have two objects, if you have the sun and the earth, the earth. So conservation of energy means that energy can't be created or destroyed. It can't just
appear out of nowhere.
Go away.
It has to go somewhere else. It has to go somewhere.
We're gonna ignore quantum physics for a moment.
Okay.
No doubt.
So it just can't come out of you can't. You're going around the sun, and all of a sudden you can't just receive all this energy from somewhere and send you flying, change your orbit, and that kind of thing. So, in a two-body problem, the Earth is always locked in orbit around the sun.
Right.
So if you have, like, say, 2 stars and a big planet like Jupiter, those stars can transfer energy back and forth with each other, and that changes the dynamics of things. So the energy of the system as a whole doesn't change.
Right. It's just the transferring that same energy around.
Yeah. Like Ben and J-Lo. Their star power is equal, but it goes back and forth between the two.
Right. Yes, they can transfer that.
Right. And power. So that has implications for other things.
Right. Jupiter.
And where, what is.
Because then if one star gets more energy, then that's going to bring Jupiter to it more, or it's going to it's going to affect it.
You're not.
I don't know.
Don't think mass here.
Energy's not mass, yes.
It is, but it's not.
Right.
In this particular thing, we're not going to worry about that.
Okay.
Portion of it. So
then, what do you mean by transferring energy?
So gravitationally, a star, they're going to exchange some energy, so this star starts to move a little bit faster. That has implications for. It's going to move quicker. It's going to move out. That's going to change.
Right. It's like all of a sudden your year gets shorter.
Right.
Or something. Happens.
And so all of that chaotic nature can, usually lead to a smaller object being ejected from the system. And what it does is it makes the remaining system become a two-body problem, which is really kind of what it wants to be.
It wants to be. Okay, so
its natural state of being.
Every 3+ body issues, like, we just want to be slimmer.
Yeah, we don't want to be a throuple.
We want to be
We
two.
We
want to be a nice even 2.
Yes.
A nice. Is that a prime number? 2.
Right. And so the thing is, though, is that when we look out into the universe, we see 3-body three-body systems.
Everywhere.
All you got to do is look to the closest star to our sun, Alpha Centauri. 3-body system.
Chaotic system.
It is a chaotic system by nature. And so...
Is it naughty?
If you look... If you look at the solar system... It's a 3-body. It's an n-body problem because you have
n-body.
Yeah, because
to the nth.
Yeah, because you have 8 planets. You have this.
God, I forgot it had planets.
Yeah, and so they get in this. They have to be considered in this as well.
Yes.
If you look at the Earth and the Moon, it's a 3-body problem with the Sun.
Yeah, and the Moon is slowly drifting further away from us.
Right.
Which is going to fuck us up
process,
in the long run.
But yeah.
I guess.
But it is different process though. Earth, Sun, Jupiter is a 3-body problem. Sun, Jupiter, Saturn's 3-body problem.
We seem to be managing okay though in our solar system.
You're managing okay, yeah, because at the end of the day, at the end of the day, Jupiter's mass is small compared to the sun.
Right. And
so
everything in the solar system is small. The mass is small compared to the sun, so it's inconsequential.
Yeah. So what it does is it kind of reduces to a bunch of two-body problems.
Right. It's like the sun and...
Earth and the sun. Jupiter and the sun.
Yeah.
Mars and the sun. Mercury and the sun. The problem is the orbits will shift over time because it's not
this
just a
sounds
two-body
like a fun
problem.
anthology. Oh, a kid's anthology series. Mercury and the sun. Venus and the sun. Earth and the sun.
And it's all kind of the same story. We all just go around the sun.
Yeah.
Or the sun's really big.
That'd actually be great if that's all it was for each one of them.
All right, so...
A golden book set.
I used to love golden books. All because you can't get an analytic solution for a 3-body problem. That doesn't mean that you don't have a solution.
Okay, it's just not analytic.
It's just not analytic. It's not that. It's not that pretty elegant equation where you can pop in. Yeah, I mean it is what it is. Where you can pop in some numbers, get something out, and that's exactly
right. It's not a nice plug and play USB.
Right. So you can approximate things.
Flip it around.
You can approximate things. So if bodies are far apart, you can approximate as a series of those two-body problems, which I talked about. Okay. So the planets are spread out in our solar system, and they're not even all lined up in the same direction, right. So it's even further from each other. And so you just say Sun, Mercury, Sun.
Right, okay. So a Venus series of two body parts. Yes.
All right. If one of the bodies has a very low mass compared to the other two, then that low mass object its gravitational effects can be ignored.
Excellent.
Got it. And it's great for satellite orbits, approximating the moon's orbit relative to the Earth and Sun, the Earth's orbit relative to Sun and Jupiter, and that is actually called the reduced three-body problem.
Reduced three-body problem.
Nice.
Reduced.
Yeah,
okay.
and that's what
the R3B.
That's what a lot of people like to use and that type of thing. But it does fail to perfectly predict well into the future.
That's science. Got to predict.
Yeah, got to be able to predict. It can get you, a few 100 million years out, but that's it.
If that's it, then let's just throw the theory away.
But then things start changing in a way that you can't.
Yeah, and then exactly that you can't predict because you have the effects of Jupiter going on. You could have a star that will.
Swing by. Like when Andromeda starts getting a little too close, it's going to fuck some shit up. It's going to cause a lot of three-body problems, I'm assuming.
Right. So there's a thing called numerical integration, which Newton also kind of worked out a little bit.
Okay.
Basically, it's where you break up the problem into...
Sections?
Manageable
sections.
Manageable.
Like we do with chores.
Yeah, and then you combine them together, and then you're like, all right.
So you break it up. You break the motion up into really small time steps.
Okay.
And then you solve it. So you go, okay, let's take a look at right now. What's the effects that everything is on the Earth? All right. And so you figure out what the net force is. And you apply that force to the Earth, and then you go forward, I don't know, a day. Whatever your time step is, a day. And then you figure out all the forces again, and then that you adjust the Earth's movement based on that, and you go forward a day.
Okay.
And so
step by step.
Step by step.
Just.
Isn't there a song called Step by Step?
Well, there's also the TV show, Step by Step. Day by day.
I just thought. Okay.
With Suzanne Summers, she was in the TV show Step by Step.
All right.
Anyway, I think it was on it might have been on a TGIF at one point.
Okay.
But
I don't know.
Maybe not.
So there are some solutions to this. We talked about Sundman, Carl Sundman already.
Yes.
But he wasn't the first one to come up with a solution. Euler and Lagrange.
Oh,
Euler.
Lagrange, known for Lagrange points, maybe?
Maybe. So Euler found out there was a solution where you have three bodies.
For those of you listening, Euler is spelled Euler.
Right. He was a man. It'd be great if he was like an oil man.
An oil man.
Euler the Oiler.
Euler, yes, founder of the Oilers.
Anyway, Euler found a solution where three bodies orbit a common center of mass.
Okay.
And they remain in a straight line with each other. So basically they're in a constant eclipse.
Oh, that's cool.
That's the coolest science fiction setting.
Yeah.
Yeah, constant eclipse.
Yeah, so they're moving in a straight line relative to each other all the time, and so it's constant eclipse. All right.
And it's always like a weird twilight.
It's like pitch black's worst nightmare. Get Vin Diesel on the phone.
All right, so Lagrange found a solution where three bodies form an equilateral triangle.
Excellent.
So they all have, think of it as a triangle, where each object is a vertice in that triangle.
Okay.
They're all the same distance from each other, equilateral. And so as it basically, this equilateral triangle just continually goes around the center of mass and all that kind of stuff. So,
and this is our favorite solution to the three-body problem.
Spheres making a triangle.
Yeah. So if you take Euler and Lagrange's solutions, they describe 5 orbits that can be described with simple equations. Those are the only simple equation solutions to the three-body problem.
Hey.
And today, those orbits are known as the Lagrangian points.
L points.
Hey,
L points.
That's where James Webb is at one of them.
Yeah, L2.
So it's gravitationally nestled.
It's in a little pocket, a little nook.
Those are the only simple solutions to the three-body problem. So you can solve it, but they're for very special cases.
Okay,
but they're kind of
useful. It has to be these scenarios. Okay,
right.
But then there's infinite number of scenarios for a three-body problem.
Yeah.
Okay.
So in the 1970s, Michael Hennon and Roger Broke found a solution involving two masses bouncing back and forth in the center of a third body's orbit. So bouncing makes it think of like a tennis ball going back and forth.
Like a bouncing
but
ball.
really and truly, they're orbiting each other, right?
Yeah.
And so this third body is really far out, orbits the two of those, Alpha Centauri.
Okay.
So found a solution for that. Also, Kepler 453, which is the Tatooine planet.
Hey, Tatooine! Two suns. God, what a hot desert, though.
So we're going to assume Tatooine is massive enough where it could be really kind of not ignored in this.
Okay.
So you do have the two stars.
I mean, here's just a side question. Can a rocky world get large enough to be, or do you have to be a
I
gas
can't
giant?
imagine that being possible. Even with like a massively huge metallic core, it's just not nearly big enough.
Yeah.
Anti-physics man?
I mean, I'm not gonna say it can't, because I'm sure that I don't necessarily know of a reason why it can't, but that doesn't mean anything.
There is
I've never thought about that. What's the mass limit of terrestrial planets?
Yeah, I don't know. So all right. Of course, the bigger it gets, the more massive it gets, which means more gravity. So you are going to, it's going to heat up that core.
You're right.
It's also going, that heat is going to be, up at that planet's going to be more volcanic. Volcanic.
Right. Because we found super Earths that are like a couple times the Earth's diameter, but they are like.
Yeah, but it also
the largest terrestrial planet is considered the one before you get too thick of an atmosphere. So it happens between 5 and 10 Earth masses. So about 2 Earth radii, apparently.
Yeah. So
not too big. Not Jupiter.
So basically, next week they're going to find a planet that just blows that out the water.
There's always an
Everything we do was
exception to the rule.
wrong. Yeah.
Yeah, so, but, I don't know a reason why you can't, but that doesn't mean that it shows up in the universe.
Right.
So, all right, so that's 1970s and 1990s. Chris Moore. Yes, that is his name. CRIS, not A. No A.
He sounds like a comic book writer. Chris Moore.
He does. He found a solution for a figure-8 motion of 3 equal mass objects. So just pointless.
That's the infinity system.
It is that's exactly what it's called.
Oh, really? The infinity system?
Yeah.
Yes.
So they're always basically the same distance from each other.
Oh, that's cool. That would be cool.
I like that. Keep your distance. I like that.
Forever.
So basically, after that, you have what's called the shape sphere. Richard Montgomery.
William Shakespeare?
Yeah. The shape sphere. Richard Montgomery came up with this. Basically, if you draw a line between all the different characters in it, so the 3 characters, you make a triangle, right? And so, and as time goes, that triangle changes its shape, but it's still always a triangle. So he found that if you map that triangle onto a sphere, we won't really get into...
this is cool. Yeah.
That the orbits actually become simpler. You would think they would be a little bit more complex, But the motion of that changing triangle is very complex. But when you map it onto a sphere, it actually becomes a little bit more, it becomes a little simpler, and you can actually see the periodic nature of it, I guess. You can see the shape of the orbits and things like that. And so basically Euler and Lagrange's solutions pop out of this pretty easily. There's also a whole lot of other solutions that pop out where you can write up, an equation.
But it has to be where their orbits are doing this triangle thing.
Well, but on the sphere, it doesn't look like a triangle. On the sphere, it looks like circular shapes, and so it's actually kind of pretty. It looks very geometric and things like that, and would I want it as a tattoo? No, but it still looks pretty cool.
Okay.
So from that, a lot of other solutions were discovered to the three-body problem.
Okay.
But none of them are likely to be found in nature.
Oh.
Yeah.
Well, then how does that work? They found solutions, but saying these weren't going to exist out in the natural universe
Pretty
world.
much. Yeah.
Well, okay.
So, I mean, it's a good way of visualizing things and finding solutions, but most of the solutions just don't work for the real world.
Yeah,
it doesn't. And what it means is that nature isn't going to. So you can get the solution, and so therefore they are permissible in the universe.
Oh, okay.
So it could show up in the universe. However, the chances of it showing up are pretty remote and almost zero. But given all the galaxies in the universe and all of that, it might show up once.
Sweet.
Okay.
But,
and then the one time it does happen, the people there will think this is normal and it should exist everywhere.
Yeah. Or that system doesn't last long.
Right.
Oh.
And it ejects a member and reduces down to that two-body problem.
Okay.
Or becomes
that two-body problem sounds like a two-body solution. I don't really see many problems with it. This is just the natural state of things.
No problems. It just is two bodies.
Yeah. So there's a
two-body
quote.
ideal.
Hey, Jackie. No.
I was gonna say, was that a puppy bark or was that a puppy sleep thing?
That was Jack licking Leia's ear.
Yeah.
So this quote is from PBS. I can't remember the guy's name, but it was on PBS. He's on PBS. The three-body problem is perfectly solvable uselessly, or for seemingly useless and bizarre orbits, except for the Lagrange points. And it may be approximately solved for useful and practical orbits with enough precision to work just fine.
Okay, that's all we need. We just need it to work.
What do we need it for other than Lagrange points right now in reality?
Satellites.
Okay.
Yeah, so you need it to launch shit places.
Oh, okay.
Yep.
Okay.
So it's very, the great thing is...
We don't need it to save civilization on another planet.
No.
Okay.
No, but...
That come in handy.
Right.
One day.
But, so we needed to launch shit now, and what's really helped us with all this are computers. Computers allow us to do it.
Our future overlords.
Yeah. But before there were computers, there were human computers that did all the calculations for you.
Yeah, human beings.
Yeah, and so it was slow, it was laborious, and computers
and
can now
unappreciated.
It was. So computers
especially if
now
you're
do
a
it
woman,
for you.
and especially if you're a woman of color.
Unless you're Alan Shepard, then he really appreciated the computers because he would die without them.
Yeah.
So
are they gonna start playing?
that is three-body problem.
Excellent.
Okay.
Good podcast.
Okay, so basically, in a nutshell, if you could nutshell the three-body problem, it's like when you got three or more bodies, things get weird and chaotic, and it's hard to fucking solve for that shit.
Yeah, things get really insane.
Yeah. Okay.
And quickly in a lot of cases. So, and it's just really hard to calculate, but that's an important part of physics and, I don't know, things that might be...
Right, because again, most of the times there's more than just two things that are, you're trying to account for.
All right, let's move on. Let's move on to a topic that Brandon really likes. Nuclear propulsion.
Excellent.
It does show up.
When things that go boom make you go far.
Nuclear propulsion actually was first thought of in 1903 as a means to propel cars, trains, and boats using radon.
Radon?
Which you don't want in your house anyway.
Right. That's when you have people come and scan your house for radon and stuff like that. I feel like using anything nuclear to propel anything that I don't know, you're in a commuter fashion, cars, trains.
That may be a bad idea.
Not great.
Right, but in 1903, though...
It was like, ooh, this could be fun.
I mean...
They didn't see a bomb go off.
No, but you also, 1920s, you had the glow-in-the-dark watches where the women were painting the dials, and basically their faces fell off. Yeah, because they're using radon and stuff like that, or something. It was some sort of radioactive material, and their faces literally fell off.
I bet
they got cancer with their jaw and all that.
There was definitely at least one, if not more, women that painted their fingernails with that glow in the dark paint.
Maybe, and then
I would.
I mean, I would.
So
instantly.
In 1914, H.G. Wells publishes *The World Set Free*, which uses nuclear propulsion. Also, in it talks about basically nuclear bombs before the nuclear bomb.
I mean, it's not... Okay, so when did we first be like, hey, things are nuclear. We can have nuclear power.
Well, I don't know about nuclear power, but, obviously in the 1920s and 30s, they knew about nuclear. Because they're trying to figure out within the terms, within quantum physics and what's going on. We knew about radioactive decay, that kind of thing. I mean, it
makes sense that then it would be like, whoa, let's make bombs.
Well, yeah. So.
I mean, it's not far. It's pretty easy to visualize the bombs before the bombs happen.
All right, so you can use fission, which is the splitting of an atom.
Yes.
To create the energy needed for thrust if you're going to have nuclear propulsion. We'll get into the two types that are now used here in a moment, but there's a third type, which Brandon I know loves. But NASA's been looking at nuclear propulsion for over 60 years. And right now, the reactor temperature inside of it would be 4,600 degrees Fahrenheit. So materials... What?
But that's it.
But
4,600 degrees Fahrenheit. Yeah. That's it.
Yeah, but so you would need materials that could withstand that temperature. For everybody else in the world, it's about 2,540 degrees Celsius.
Okay. Isn't Brandon doing this part?
Oh, I'll get there. Don't worry.
Okay.
Yeah. Nuclear propulsion could allow for, one of the benefits is it could allow for more flexible abort scenarios, which Brandon added a question mark to that.
Basically asking, what the fuck?
Yeah, what?
Yeah, so...
and is that a good idea to abort
Hop in the nuclear escape pod.
Well, so basically, if something goes wrong, there's a few more options in which the astronauts, further along in their journey, they can now escape and get back home.
Okay.
So
okay.
By
so
using
so in the scenario that we eventually send astronauts to Mars, some shit happens. There's maybe an escape pod powered by nuclear power that they can return home in a reasonable amount of time.
Yes, exactly.
And not starve or dehydrate to death.
Right. So, yeah. So that's.
I mean, when in Rome.
Yeah, I mean, straight from NASA's website. So basically, it's going to allow for them to be able to, because if you don't have nuclear, that means you got chemical.
Right.
And so you're going to be.
I mean,
nuclear. Chemical is not as efficient. So then it.
Would chemical be more combustive or explosive?
Nuclear is.
The nuclear?
Well, I just mean
okay,
like more sensitive.
I tell you what. We'll get to
nuclear
it.
Would be.
We will get to it.
Okay.
All right. The energy density for nuclear, for uranium-235, is 560,000 times that of hydrogen.
Jesus Christ.
So you get more energy from nuclear than you would from a chemical reaction like with hydrogen.
You can imagine like uranium is like more sludgy, and hydrogen is more.
Now forgive me, U-236, isn't that what we use for RTGs for like Perseverance and Curiosity? It's like one away from the actual nuclear weapons for RTGs.
Sure. This is the only one that I have a number on.
Okay.
So it is basically it is more efficient than chemical rockets, and it will give you more thrust than chemical rockets.
That's why we use
That's why you have more scenarios with nuclear in that if you're further in your trip to Mars, shit goes wrong, you then can use nuclear propulsion to get you home because it'll give you more speed to get back home. Whereas chemical reactions, just not as efficient.
I am going to make a Weird Al-esque parody band called My Chemical Rockets.
All right. So there are two types of types of nuclear propulsion that they're looking at now. There's thermal and electric. Thermal has high thrust and twice the propellant efficiency than chemical rockets. Basically what it does is it transfers heat from the reactor to liquid propellant. The liquid goes to gas, expands through the nozzle, producing the thrust.
So extremely similar to just nuclear plants in general, just creating,
There's also electric.
Oh, I love this.
Which has a lower thrust than thermal. But what it does is it generates electricity that positively charges the gas propellant, makes it turns it into positive ions, and that is pushed out through a thruster, which gives it the thrust. It's not as its thrust is not as great as thermal, but it still gives you the thrust. So those are the two that they're looking at now.
And we use nuclear stuff for like New Horizons and all those spacecrafts that are going far because we need it.
Right.
Well, that's
batteries. Last longer.
Yeah, those are batteries, not necessarily for propulsion.
So, here's the question.
That's fair. That's true.
Here's the question. Can we use a bunch of bombs, nuclear bombs, to make us go really fast? The answer is in theory, yes.
Can we, Brandon?
In theory, yes.
You may be asking, why is Brandon here in this episode? And I'm going to respond that one, Mike hates the sound of me pouring things. And number two, because there's spaceflight involved. And when there's spaceflight involved, I get very excited. Enter one of my favorite projects of all time, Project Orion, which I was going to say at some point is going to show up as a shot episode, 100%, because I love this.
Oh, yeah.
All right. So the idea is, just like Mike said, is you have a spacecraft. Well, it's two different ways of thinking about it. But the main one is basically you have a spacecraft in space, and it's moving forward, but then it poops out pellets of nuclear bombs. And these poops explode.
Nuke poop.
Yeah, nuke poops.
I'm really so happy that you used my thing in the notes.
Oh, did I?
Poops out, yes.
Oh.
I didn't even see that.
A spacecraft. I have a spacecraft.
All of our brains work the same way.
That explode.
I didn't even think. I think of like rabbit poops, like little pellets. Or was it wombats that do cubes? Anyway,
yes.
These spacecraft will poop out nuclear bombs, explode, and then you have this huge plate on the spacecraft, and it will use the shockwave. Not shockwave's bad term in space, but it will use that force of the bomb to propel it. Right. And you drop hundreds of these things to reach like 1% the speed of light. How do you slow down? Nuclear weapons. Nuclear bombs. And just keep popping them off, and you'll slow down eventually that way as well. But it's just an absolute batshit cocaine straight line theory, and I love it so very much. Now, the other idea was how do you get to orbit in the first place? And this was, well, what if you also use nuclear bombs and use it as a force to actually get you into orbit?
Yeah,
and you know what? This was tested.
What?
I think it was like November of '59.
Of course it was tested.
Yeah, but they didn't use nuclear bombs, right? It was chemical.
It was
they were chemical bombs.
And they only got 10 meters up, but still.
So it's feasible.
I mean, the logic of it, using the force from the explosion to propel, it's sound, it makes sense.
I mean, at the end of the day, rocket launchers just control explosions anyway.
Yeah,
But we're going to go back a little bit and kind of start where this came from for a moment. Back in 1946, Stanislaw Ulam proposed it, and he actually worked at Los Alamos in 47, and he took this as he's working next to literally Einstein and Oppenheimer. And he had this idea, and he tried proposing it, but it wasn't really a serious idea because it didn't have any names or theories back to it. So he actually went to a name we love in astronomy, Freeman Dyson.
Dyson sphere. Also expensive vacuums.
Also expensive, but a different thing.
Yeah,
so
different Dyson.
So Islam there went to Freeman Dyson to get his political power, and it got enough to was given $1 million a year, which back in the 50s was a lot of money, to study and propose. Because at this time, we're still trying to find applications for nuclear power and nuclear energy as opposed to just bombs. So they thought, what if we actually use nuclear power spacecraft to poop ourselves to other stars? And the benefit, actually, is that you can have far larger spacecraft than like the Saturn V, even. Because as opposed to a 3-person capsule like Eagle or Snoopy, you can have 150 people in this massive capsule that uses this nuclear bomb energy to launch itself off.
Leia made an appearance. Special
Leia
rule.
made an appearance. That's right. It was a secret.
Secret rule.
And speaking of secrets, the paper that Islam wrote in 1946, at least in 2002, is still classified.
Really?
Yeah. So most of this stuff is still classified. Anything dealing with nuclear is probably going to be classified.
Right, of course,
So for about 1 to 2 decades, it was seriously studied by DARPA, for example, and a couple of other agencies, until we signed the Partial Test Ban Treaty, which basically says you can't explode nuclear bombs in outer space.
In the atmosphere, yeah, because we all live here in this
damn
planet.
hippies.
Can we not fuck up the planet?
There
Which we're already fucking up.
There was also fear of fallout.
Yeah, fallout's an issue.
Yeah, because we're dealing with shit that basically either kills you immediately or kills you slowly in a horrible way over time.
The big problem wasn't exploding bombs into space, which I think Russia just talked about a couple months ago, and a different story. But it was the fear of getting those nuclear explosions into space in the first place, which has to be done by a conventional rocket launch. So
by an explosion.
By another explosion. So let's say, for example, we have our big giant 75 rocket. What happens if it explodes on launch pad, carrying megatons of nuclear explosion on top of it?
Yeah, that's bad news bears.
Whoops, Daisy.
Yeah, I mean, people freaked out
goodbye,
with
Florida. We'll see.
People freaked out with, I want to say it was Cassini.
Yeah, with the RTGs on there.
Yeah.
So I forget who it was. I was at the FAA or the FAST, something like that. They had to have special casings around these RTGs. So if it did explode, the rocket explode, that this RTG would not leak at all, or do what it does.
Right. I mean, it's a risk. If we're gonna play with nukes, this is the risk. If we're gonna play with these elements, we have to be prepared for the consequences of playing with these elements. So
this is 100% going to be a shot episode because I want to go more in depth on that.
Yes.
But I love Project Orion.
Well, then let's move on.
Okay.
All right, one final thing before we call it a day. It's quantum entanglement.
Oh boy!
It is a bizarre and counterintuitive quantum phenomenon.
How bizarre!
Yeah. So.
Well, anytime you mention quantum, things get fucking...
Where two particles are connected and share information, even when separated at large distances.
Isn't that also spooky physics? Or is that different?
Nope, it's the same thing.
Hell
The term quantum entanglement was coined by Edwin Schrödinger in 1935.
Oh, there we go.
Yes, of Cat Dead and Alive, or Alive, and or Alive.
It is in response to Einstein... Podolsky-Rosen paper that said quantum was incomplete and not a theory that really describes nature.
Now, really quick, I want to point out in the notes, he has Einstein, Podolsky-Rosen, initials as EPR, and that makes me think like of a boy band. Here comes EPR! And it's like Einstein coming out and Rosen Podolsky doing the thing.
Yeah, so it's
dancing.
It's known as the EPR paper. And so Schrodinger took exception to the EPR paper, and he wrote a paper, and
I take exception. I like the battle of papers.
He wrote a paper. He also wrote a letter to
That's
Einstein.
a scientist fight right there.
And in it he coined the term quantum entanglement. And so what is it? So
it's a cool term.
It is.
All right. So I don't know how well this is going to work, but I have 2 coins for people that are watching, which is nobody. But I have 2 coins.
It doesn't matter.
Yeah. And they are 2 quarters. One is the Georgia quarter. One's the Arkansas quarter.
Oh, okay. Does that matter for the experiment?
These are not entangled. So if I were to flip them,
Okay.
50-50 shot, heads or tails, it doesn't matter what one coin gets, the other one still has a 50-50 shot.
Unless it's Rosencrantz and Guildenstern are dead.
Okay.
Literary reference.
Yeah. All right. So let's say I do a magic trick, though, with these.
Oh, we've been watching that magic show.
Yeah, so exactly. Just like that.
Hey.
Except with coins and not my thumb. But anyway, I'm doing a magic trick. And so I magically entangle these 2 quarters.
Like a witch.
Right. And so I give one to you and one to Brandon.
Oh.
Thank you.
And you guys go on this magic adventure in opposite directions. So you get in a rocket. You get in a rocket.
Can I have my coin? You never gave it to me.
You get in a rocket and you go opposite directions. And you guys are on opposite sides of the solar system from each other.
Okay.
But they're magically entangled.
Delicious.
So what it means is if we flip one and it comes up heads, the other one is automatically tails, no matter what.
Okay.
If I flip this quarter and it comes up tails, the other one automatically heads. It's the opposite.
Will that happen right now? Can we do that? Will it happen?
You can do it. Do it.
How do you flip a coin?
I want to hear the cool flip sound.
It's heads.
What is it?
Heads.
Heads. So this one is automatically tails. Crazy how that came up.
Flip it though. Let's see if it comes up actually tails though.
Let's do statistics.
It is tails.
It did come up tails.
Hey!
Whoa! Spooky.
All right. So you guys have these magic quarters, and Leia off.
Oh well, she came back. She's very insistent today. Go lie down, honey. Go lie down. Go lie down. Go away. Go away.
All right, so you guys go on opposite ends of the solar system. You flip yours, and you have a 50-50 shot of heads or tails, right? But for Brandon, it is a 100% chance.
So I determine Brandon's
that it is the opposite of you determine.
That's wild.
It's whoever goes first really determines
That's
the other
wild.
fate.
Yeah. Nose goes.
But since we're married, you go first. And Brandon just has to deal with it.
Right.
So you guys automatically know what the other person has. You are on opposite sides of the solar system, but you flip your coin, it comes up heads. You know instantly Brandon has tails. So you know this information. Now, see, Einstein's big problem is that nothing should go faster than the speed of light, and that includes information.
Right.
And so that information is going to take time to go from you to Brandon because you go, hey, I got heads, but Brandon already has tails. And so Einstein says, because of this, it violates relativity. Quantum physics is incorrect. That it is not a real theory of the universe.
Look, man, things just get weird.
Things do get weird.
Things just get weird. Einstein.
And so, but
people can blunder now and then. Yeah, have big blunders. Exactly. It's fine.
Yeah.
But you automatically know what Brandon has, and Brandon automatically knows what you have. And so it seems like this information has gone faster than the speed of light. So these are quarters, though. So the question is, does it really show up in other things in nature? Leia, go lie down. And yes, it does. They're a quantum tail.
A quantum
tail.
Ooh, another golden book series.
Take that, Fievel.
So in physics, you can entangle two particles.
Okay.
We've done it with photons and the such. Basically, if you have two particles and you do a neutral spin on them, means that one of them is up, the other one is down. It's always like that. So it's a neutral spin. You can separate and measure them. So you've created these particles in such a way that they're entangled. We have done this, with photons.
This is crazy that we can do this.
Then you separate them. You measure the spin of one, and you know the spin of the other one. You measure it, and it's the opposite. And so Einstein referred to this as a spooky action at a distance. It violates relativity, which is what he was all upset about. But Einstein was the first to kind of think about this. And his thoughts were conceptual, though. He didn't really have any math to back it up.
That's not like Einstein.
But he's a thought experimenter, so it might be hard. It might be harder for him to do a thought experiment on this kind of thing because
the whole EPR paper was a thought experiment about it, and so he just couldn't back it up with math. And to be fair, it took another 30 years before somebody could
to get the math for it.
Well, to really figure it out, and it was an Irish physicist named John Bell.
He had the luck. He was lucky.
Right.
He had some charms.
And so he turned the ideas into equations that could then be tested. He didn't test it, but he came up with.
He was like, "Look, I did the math.
It's called the Bell inequality or the Bell theorem or something like that." Okay. There were three physicists that really took on the mantle of trying to prove it or disprove it. And Alan Aspect, John Clauser, and Anton Zellinger, and they won the 2022 Nobel Prize for experiments with entangled photons, establishing the violation of Bell inequalities, and pioneer quantum information science. And so they got it for quantum entanglement. We don't fully understand it, but we know it's a fundamental aspect of nature.
Well, 2022 for the Nobel Prize for it. I mean,
One of my favorite things is in Planetarium shows, we get all sorts of great questions, or fun, weird, strange questions. And typically you have
my favorite question was, what's that behind you?
Oh, God, that's a whole nother story.
That's spooky physics right there.
That's spooky physics right there. I don't like that question. But typically you have an answer, or you can speculate on an answer. But anytime somebody asks anything about quantum, like, I don't fucking know.
I know. It's like...
And that was my quote. I don't fucking know, you 12-year-old.
Yeah, quantum is so weird. And
yeah, it's I mean, but it's strangely charming.
Nice.
It's strangely what?
It's strangely charming.
Oh,
when you think about all the up and downs.
I swear to God, I'm going to finish that drink because this was a fabulous joke.
I actually put drink on there, so. All right,
I
tell you what.
That.
Let's talk about quantum in The Hangover, because this is about
let's talk about quantum, baby.
Okay.
All right, so thanks for joining us, and whoever joined us, thanks for joining us. Come back and see us again in 2 weeks, and where we will. What month are we in now?
Oh
April.
God, what are we? Yeah.
We're going to talk about what's happening in May.
I saw the 4 on my computer. I did January, February, March, April.
That's what I usually do. Yeah. May High in the Sky.
May High in the Sky.
It will be our next episode. Yes.
Yeah. So
we may have some scheduled changes coming up, just because we're going to have some visitors in town that we may then have to adjust the schedule later in May.
Hold on, let's just see if it happens.
We'll talk about it.
I'll do the episode myself. Don't worry.
There we go. Yeah, it'll just be Brandon time.
That'd be great.
Yeah.
I'll send him the OBS profile to set up.
God, how deep down the rabbit hole will I go?
Anyway, thanks for joining us. We'll see everybody in 2 weeks. Cheers, everybody. Bye.
Susu.
Bye. Now, if you're with us now, stick around. We will be right back for The Hangover.
Cheers.
Be right back. Brandon
were just talking about
doesn't
India.
know how time works.
We were just talking about India, which is offset by 30 minutes, so I got very confused. So I think I was, where was I? I was either in Texas or I was in my bed recently, and I woke up.
That's a big difference.
So you come
Well,
from
you think so, but I woke up, and for like a minute, I couldn't remember where I was at.
Oh God, you need a.
And that happens. That happens often.
Well, luckily you're getting a break from traveling, so you can.
It's just a whole. I haven't been home in one location. I can't say one location. I've not been in Utah this long consecutively since I first started this job.
I mean, that's wild.
I'm here for like 3 weeks.
Yeah.
I've never had that since I first started.
Well, now you got it.
Now you got it.
Yeah.
Oh,
all right,
Jack.
Bring us in.
All right, so.
Welcome to The Hangover.
Welcome to The Hangover. Brandon, you were talking about, hey,
what are we doing? Nothing, we're just hanging out. We're just chilling. We're just in The Hangover here? Now. It's
I don't have the chat open.
Elizabeth. Well, it's in the... Oh, you don't see it?
I don't have the chat open, no.
Oh, wait a minute. It's not showing up over on... It's not showing up over there.
I think because there might be... Oh, it's not showing up over there. Oh, no. It's just a delay. It is, but because we have this thing going there. Where's your job?
Oh, wait a minute. It's way down there.
Yeah, it'll pop up. What is your job? Well, Brandon travels for CwC.
I did.
Or he did travel for CwC and installing planetariums and stuff. So now
I've been to 81 planetariums in the world.
That's pretty cool, though.
It is pretty cool.
I mean, I know it's like an exhausting and hard and sucks to travel all the time.
I thoroughly appreciate it. And oftentimes, like, I've loved every international travel except for Bangladesh. Even then, I appreciated aspects of it. But I understand like how beneficial and privileged it is to get paid to go travel the world. Mm-hmm. Like I've had amazing experience and some fantastic
good ass food.
Some damn ass good
food. He sends us pictures of foods on his travels, and it's like shit you see on a travel show, and I'm just
Okay, I got a story about that.
Okay,
but top 3 places for food. In no order, but Mumbai, Singapore, Gwangju, Korea.
Ooh,
those are the S tiers.
Yeah, I would say, okay, if you're ever back in India, Hyderabad, because that's where all the spices kind of come together.
I'm kind of pushing to go back to India for various reasons in a month and a half, 2 months. I would love that.
Oh, well then, June, for the India conference.
Nope, Lucknow for an installation up there.
But anyway, in Hyderabad, that's kind of in the center of it. That's where you have kind of all the spices kind of meet together. And so there's more spices in Hyderabad than like in Mumbai and New Delhi and places like that. And so it's, oh my gosh, so
I was, so of those 3 places I said, Korea has the most familiar flavors, I guess you could say.
Okay.
Like, you can kind of pinpoint some of these flavors, but done in their way, and the quality is fantastic.
Well, yeah.
But in India, you have so many new flavors thrown in there. It's just a whole new palette, and it's glorious. And then Singapore is its own glorious smorgasbord.
I did like Poland.
You like the pierogies.
I like the pierogies. My favorite part though was getting the tour pierogies. The training was over. Yeah, it was over. And the Planetarium director he and his partner took me to some restaurant. And I got basically a tour pierogi. So Poland is not a big country, but the regions have different pierogies and different styles and things like that. And it was, just amazing to have.
The other thing that I hear you just give all the compliments about, all the love about, Peking duck.
Peking duck.
Peking duck.
Oh, I do love a good Peking duck.
Legitimate in China, Peking duck apparently is amazing.
So I had gone to a restaurant. We were going to talk about quantum physics, but this conversation.
We'll get there. We'll get to some quantum peaking.
So I was giving a training. This was in Beijing, and I was giving a training, and they're like, we want to take you out. And I was like, I really don't want to. I don't want to. But they're like, nope, we're going to take you out.
Yep.
The whole intention was to try to get me drunk.
Yeah.
Oh, I love it.
Yeah, it's a big thing.
And
it is
that drinking culture, yeah, like afterwards.
But they don't know,
right? And so but I told my handler, my translator and guide and everything,
agent.
I was like, look, I have like a whole podcast where this is what we do.
Drink, people.
We drink. The weekends are made for drinking.
We drink and we know things.
And it's not going to happen, especially since I know what these drinks look like, where they come in these thimble-sized fucking shot glasses.
It's like Legolas versus Gimli.
I mean, they really are thimble-sized. I mean, they're a little bigger than thimble-sized, but they're not that big. I was like, it's not going to happen. It's really not going to happen, but we'll do it. Mm-hmm. And so we went. We still had the bottle. The bottle.
Yes.
The bottle.
It's a really cool bottle.
Gotta keep the bottles.
Yeah, and so I loved the bottle so much. I was like, "Can I keep this?" And they're like, "Yeah, sure."
Weird American.
Weird fucking American.
I have a bottle of alcohol or whiskey from every country I've been to.
That's awesome.
That was my thing. Yeah.
That's awesome.
So, but also in this was, and it's very communal. So it's got you have this big Lazy Susan that has all the food on it, and you just kind of rotate it and you grab it, and Peking duck was one of them, and oh my god, it was amazing.
I'm jealous. I've never had duck,
it
was
absolutely amazing, and I
get
was
it.
like, I really just want to take this whole plate. And just,
you have to share.
but also what's funny is it's Lazy Susan, so you do get this like little rapper scratch going, DJ scratch, where like people.
Now, was the duck like as its duck form still?
No.
Okay.
It's sliced.
I just picture the
like the pig with an apple in its mouth.
No, but also in a Christmas Story. And they go to the Chinese restaurant and they bring out like the duck that's still in like Peking duck, but it's in like its duck shape and everything. And I would just want to take the beak and put it in my mouth like Pringles chips. So then it's a real duck face.
All right, I need to know more about this. Have you tried the Chinese medicine? It's good for women. I need to know more about that.
Yeah.
But also, first time I'm there. So China is a really
the duck. It's good for women, is it?
Oh. So
it's good for everyone.
Do I got to add more duck to my diet?
Duck bacon.
Duck's
I love duck
it's
bacon.
A fatty meat though.
Get that duck bacon. Hell yeah.
China is very interesting. I did enjoy my time in China. It doesn't mean I really want to go to China, because as soon as you land, you immediately feel like you're going to be arrested, because the very first thought,
what you say.
The very first thought that always popped into my head when I'm handing over my passport was free Tibet.
Don't say it out loud. Just don't say it out loud. They can't read your mind.
Don't even say it in the podcast before you go to China. Don't do that.
And so, you can't, but whatever. So the first time I go there, I mean, it's very interesting where you have what would appear to be an affluent business or an affluent house. Right next to it are the slums of wherever you're at.
Got stories about that with every place I've been.
So I can't remember the city I was in. It was near Shanghai, but I can't remember the city. But then we were in the science center, and somehow with my agent, I ended up in like the CEO's office. And I don't even know how or why I ended up in there. It was just me and Lee. I don't even know why I was in there, but there was a little statue of Mao on there on the desk.
Naturally.
Lee was like, "That's Mao." And I'm like, "Oh, I know who Mao is."
Yeah, we're well aware.
Yeah, we're well aware of who Mao is. But anyway, So he was like,
is it meow?
he was like, all right, so we're going to go meet the CEO at this restaurant. You have to go. It would be
like an insult.
Yeah, if you didn't.
If you don't, yeah.
And
now GPT.
Mike's tongue is blue/green for the Neptune drink earlier. It makes me very happy.
It is.
All right. My Romulan now. And so it was crazy because Lee was like, okay, he is going to give you a compliment and you guys are going to toast each other. You're going to toast each other. And I don't know if that CEO was trying to get me drunk or if it was just what happens. But it was my first experience with it. And, there were so many toasts going on.
Yeah, it's part of the culture.
Lee finally stopped just telling me whatever the toast was. So he could be telling me that
was Lee having the toast with you guys?
No, Lee doesn't drink.
Oh.
So that's not fair.
Well, he's got to
get back to
the well, I have the story later on.
So the CEO could be telling me that, or at least at the time he didn't drink. So the CEO could be telling me that I was just
right, and Lee's
dumb
just
as shit
telling you what you know.
Well, but Lee had stopped telling me, and so it was just a bunch of like boom, and we're gonna take these shots.
Yeah,
together.
I think that's just the culture. God, I feel like I would call us like an international incident.
Brandon's gone.
Sorry, no, I have
something.
I'm just getting prepped for stories.
Go.
Man. Leia, go
Leia,
away.
go lie down.
Go away. Go away, honey.
Go.
Go away, honey. Go away. That's her off command.
Oh
just
my
to
God.
anybody out there.
so
Leia's off command is
today.
go away. She's very needy today. She went outside
So,
to the potty.
So for those of you on the YouTube, which I guess Hangover is always YouTube anyway, here's
Yeah.
one of my top 7 favorite bites of all time.
It's blurry.
It's a little bit. Oh.
Come on.
It looks good, but it's blurry.
I
sorry,
see lettuce.
it's blurry. All right.
I see lettuce.
Yeah. So
Leia,
it was a Korean barbecue. And you eat the barbecue with the lettuce wrap, so you put everything on it: your dressing, your meats, your I don't know what vegetables it had.
One or two bites in that.
There. Phenomenal! Holy shit!
Come here.
Oh gosh,
so you had talked about the CEO wanting to meet you and things like that. Hey, Leia. So 2 stories. Number 1, let's go with Korea first, and then wanting to get puppy dog.
All right, good girl. Good girl. Good girl. All right, go lie down.
So you talked about in China going out with people and intentionally trying to get you drunk. In Korea, the professional expectation is you go out with your coworkers and drink like constantly. So it's almost impolite to have an empty shot glass in front of you.
It's like that in Japan too, I think, where it's like after the work day, you coworkers go out and they have drinks and.
Yeah, we saw it on that show where it's like.
Yeah, I've seen it on various
all night
shows. Yeah, it's like a.
Yeah. So the first time we go out, we're trying to figure each other out. Who are we? What's going on? What little shots here and there, which is fine. But then once they figured out that I can drink and I enjoy it, the second night we went completely out. So this was my favorite soju, Nine-Tails Fox.
Oh, Nine-Tails Fox!
Nine-Tails Fox.
Oh, that's interesting because Naruto, the Japanese anime, has the whole legend of the Nine-Tails Fox built into it. So
I'm sure it was good luck drinking that.
No, which one?
Naruto.
Well, okay, so we haven't gotten, or we started watching it, but then we never.
There's so many episodes.
Because
a lot of it's filler, but Naruto Shippuden's the best one again. Anyway, continue, Brandon. Nine-Tails Fox.
Whoa, you guys interrupted me non-stop.
No, we let you go.
We have conversations. That's what it's supposed to be.
30-minute podcast is
because we gotta talk. We gotta have conversations. It's not just a note read.
And your notes.
I feel like I did better.
You did.
And your note, I basically said nothing up until Project Orion.
It was good.
Whatever.
It was fine. Anyway, continue. I said it was good. Continue with your.
Oh, no, I will interrupt if I want to.
Wait, while I am talking, Mike and Liz.
Do you have the stick? Oh, we don't do rules in this episode.
It's the hangover. We don't do that. But take a drink if you want to.
Take a drink if you want
to. The second night we go out and with Sam and Mr. Lee. Sam's right now in Texas getting ready for the eclipse because this is his first time back in the U.S. since he visited 8 years ago. But we went through Sam and Mr. Lee.
Lee's here in the U.S.?
No, Mr. Lee's in Korea. Sam is in the U.S.
Oh, okay.
I would love to see Mr. Lee in the U.S. That's a whole different thing. But so the second night we go out, we go to get some amazing barbecue. We had amazing food. We go through 8 bottles of soju between 3 of us.
Wow. Wow.
And
I mean, you had to be feeling that, though.
Well, that's a secondary story after this one. And this was the day that we really got into Korean politics. We talked about North Korea. And the moment I brought up North Korea, they go, "Yeah, we'll be unified in 70 years."
What? 70?
What? Yeah, they go, "Oh, it's going to happen. It's just a matter of when."
Wow.
It's just an assumption it's going to happen.
Okay, yeah. I mean, yeah,
I mean, I never thought about the South Korean perspective on North Korea.
Yeah, no, I wanted to know.
Even want to reunite.
Speaking of that kind of stuff, though, in Poland, I had a conversation. All right, so we're doing the training, right? I go to lunch with one of the people that were in the class. I don't know if this was pre-class or what, but we were talking politics. And okay, I've had 2 people tell me they don't really follow politics. I felt like one was like, I have to say this because the room is bugged. But this guy is like, no, I don't really follow politics. But then he told me we hold Napoleon in high esteem, and I was like, I must know why.
Yeah.
Why do you? Because
I get it.
And he said was because Napoleon let us be ourselves.
He let them keep their culture and their instead of forcing them to become French or whatever.
He was like, we don't like the Germans, obviously, and that we don't like the Russians, obviously. And so, but we love Napoleon because he let us be who we are.
Right.
I guess it's similar to who you ask about Alexander the Great. Either, oh yeah, great historical figure, or he's literally Hitler. It just depends who you ask.
Right. Yeah.
But the other person was in China, and and I get it. There's only one party in China, and so
there's only one China as well.
There's only one China. Exactly.
Since you're going there, I thought we'd get you on record saying that.
Yeah, I appreciate it. Well, it's the official stance of the U.S., right? So, I really wanted to follow that whole conversation up with the guy in China more, but it was really weird. What at the end of the day, training is done. And I get to walk out by myself back to the hotel, which was fine. But they line up at this particular museum, security. Security has the whole very blue uniform, which is what the Chinese police have. And so it's very distinctive. They also had, I want to say they had helmets. And you could also see the little billy clubs that they had attached to their thing. Guns? And I was like, what are we fucking expecting? What are we expecting at this place? Is there going to be a riot?
Sorry, continue, and then I'll jump in.
But it was really weird walking past all that. And I'm sure they're looking at me like, wait a minute. There's a white dude who just walked past here. What is going on?
Like in the place in South America I've been to, and in India, you talk about the batons they had. They straight up in these countries had the assault rifles. Every single policeman, paramilitary, they had assault rifles just walking through the streets. And it's the strangest thing because you stand out, and you have to talk with them to try to get through their gate, and you don't speak their language, they don't speak English, and you're trying to use Google Translate, and these motherfuckers have assault rifles saying you can't come in. It's closed. And you go, it's closed because of me. I need to get in there.
Yeah.
Look.
So I mean, like in China though, so they would have, like if you go by a construction site, they'll have a fence and they'll have like little signs on the fence.
Yeah.
But they have that in China as well. But they're political.
Internet.
Oh, and you're back. And you're back.
We're back.
Okay.
You've been choppy the last 2 minutes.
Oh, have we? Okay.
And so, like, you'll see a thing which is clearly for the Chinese military. I don't know what it says, but it's clearly for the Chinese military. It's got like planes and shit.
Oh, right. You can tell propaganda.
Yeah, you can tell propaganda. It's completely propaganda.
It's a little over the top.
Oh shit.
It's great, though.
But the best person I have ever met.
The tea lady? No,
the
that was
tea
in
lady.
India. No, that was in India.
Oh,
it was in India.
Okay, the tea lady in India.
So
we can go off on the tea people. God damn, I love the tea people.
I had gone to Hyderabad in India for a training, and so we're doing our thing. It's the very first day, and at 2:00, shit just stopped, and this little lady.
2:00.
Yeah,
That's tea time. Tea time.
To me, it's always 2:00, but whatever time it was, this little lady. Old lady.
Did she have a little hunch while she walked?
I think she kind of did, but in the typical, Indian garb, that type of thing. And so she comes in and she makes us tea, and it was the most amazing tea I ever had.
It was pure chai.
Well, you don't drink hot tea.
I don't drink hot tea, and so I had this. And it was amazing, and I looked forward to her. Oh,
is there a comparison
it had like a spice to it. It had a spice taste to it, and it was so good. And I look forward to her coming every single day. And on the second day, on Tuesday, I basically thanked her for the tea and just how amazing it was and how I loved it. By time the 5th day came, I was like, you're coming home with me.
I'd be okay with that.
You're coming to America. But
another story about that.
But also it was, you did have I had all these rupees that I could either bring back to the US and cash in and put it back in my account, or I could just somehow get rid of it in India, which is actually the easier thing, and you don't get charged. Easier. You don't get charged anything. So like a fee to turn it into US dollars. And so I gave her a lot of that money that I had left over, and it was roughly something like, I would say something like $80 US.
That's a huge amount of money.
That's a huge amount of money, and in India. So, but she did not want to take it at all, and
because they don't have a tip culture.
It's an insult to do that.
And so it was that she was very, didn't want to, do it. But the guy who ran the planetarium was like, yeah, you can take it. So I don't know if I ever really stepped on anybody's toes, but I didn't give a shit, because that tea lady, I love her. She might not be around anymore, but because she was really old, and but she was so nice. And by the time the Friday came,
you could have bought maybe some tea and brought it back.
Well, I don't know what she was using. I should have.
Did Brandon bring some back?
I guess I should have asked, but she would come to me first because she knew that I was just so excited that she was there, and she and I.
Oh, you brought back some teas.
No, it was a gift from Korea. They gave it to me.
Oh, that's right.
This got me through COVID. Holy
what?
shit.
I've never had oolong tea.
So that was the first one I ran out of, because I love oolong's my favorite tea, but this volcanic oolong tea was phenomenal.
Is it like, what kind of taste does oolong tea have?
So it is surprisingly smooth and light for the caffeine and what it is.
Okay.
But it's my absolute favorite kind of tea. It's way better than Earl Grey.
Really? Okay.
And I do want to make an announcement. This is from the chat for all that are interested. The University of South Carolina women's basketball team has won the national championship for basketball. Now, having said that, I do have a connection to that, and that my parents are very happy now. So if I did want to call my parents,
do they care about women's basketball?
Huh?
Do they care about women? It's anything University of South Carolina.
Yeah, yeah. But my mom, very passionate.
It's the Father, Son, the Holy Ghost, and college sports.
Yeah. So my mom would. She'll watch a game, and she's very can get very upset if things aren't going their way. Yeah. But the South Carolina women went undefeated this year, and they were number one from open to close. And
they basketed that ball.
And they did basket the ball, and I guess they won. I don't know, but yeah. So my parents are are in a very good mood. So now's the time to call them.
Let's hope they're in a good mood.
In July. Oh, they will be, because I'll be there, and then you're there, and they're gonna my whole family. You know, you're sitting there thinking,
get so many Michael George stories.
Yeah,
so
but
many
report back.
Yes.
Here's the thing.
Very exciting.
Liz thinks she's gonna get all these stories, but the conversations are gonna be all about her. There's going to be questions and all of this.
No, I'm like, tell me about this mohawk. How'd you feel about it when he was a kid?
I get it. Oh, I'll tell you how they feel about it.
I know they don't like it.
We can put it together. So there is just one last international story that I will tell here. There's about 6,000 I could do. But last couple weeks ago in Korea, because you had talked about it's like being on a travel channel with all the food and people and experience and drinks I have. And honestly, it is. I can go, it's comparable when I'm either with somebody or going exploring this random city on my own and getting these like hole-in-the-wall places and this amazing food and experiences. But it was Sunday in Gwangju, which is like this office city center. Like, you only go in the city center for work, so Monday through Friday situations. So on Sunday, almost everything was closed. And that was my one day off I had.
So Utah.
So yeah, also Mondays for Utah. But so I'm just wandering around, at least in downtown. So I'm just wandering around Gwangju. Great huge buildings around me, really cool parks all around, but everything's closed. So I'm like, well, this kind of sucks. So I go to a place called Max with 2 X's. It's like Walmart, but with a whole bunch of small stores inside of it that goes like 3 or 4 stories up. It's really cool.
Oh, wow.
And I go, well, the restaurants are closed. The places I want to go to are closed. So I buy a bucket of fried chicken. I take it back to my hotel room. And I don't speak Korean, so I can't just watch TV, but I hook my laptop up to the TV and watch Anthony Bourdain in Korean. And I watch Bourdain in Korea. So I'm in Korea eating a bucket of fried chicken, watching Bourdain in Korea, going through experiences I just had in Korea. And as I'm eating my fried chicken wing, I go, I'm just like him.
I mean, that's a beautiful moment.
I did learn from that the youngest person typically pours the soju. So say hi to my nine tails. So the next day we go out and we have a soju, of course. And I am not the youngest person. But I learned recently that the youngest person pours a soju. So I take the soju and I pour it for everyone. And they all laugh and say, now you are Korean. Now you get it.
That's fun.
Yeah.
Nice. Well done.
I also learned that my favorite phrase is komatai.
Komatai?
Which is, this is fucking delicious.
Ooh.
Oh.
So when I'm at a restaurant with them and this bite is really good, I say, komatai. Everyone with an earshot cracks up at me. They just start instantly laughing. So that's how I know it's good.
Yeah, in Japan it would be oyashi. Oyashi.
Oyashi?
Like, this is good. Like, oyashi.
I want to go to Japan one day.
I watched one.
That was a very very
I do want to go to Japan. I do want. I watched.
We don't have to. I'll say that.
No, I do want to go to. I watched
We're not going to Japan.
I've watched one Korean drama, and so there's some Korean words that I picked up from it.
Because I had said, like, in a chat or something, or I think on the call, like, how to say thank you. Komatsuda, and this was like, oh yeah, that's thank you, because that one Korean show you watched.
All right, but more importantly, palship. Palship means bullshit.
Ah, komatsuda.
Palship.
I like the sounds. I like the sounds of Japanese and Korean, how their inflections and the sound of their languages.
Yeah, because like with, German, for example, it's...
Elizabeth says you pronounce your Korean like a Japanese person. So cute.
I don't know what that means. But it's hilarious.
Well...
means that you're pronouncing it.
I mean, that's
wrong.
cool that at least you sound Japanese when you're pronouncing it, and not American.
I would say thank you, and people like, oh, you're not from here. It's fine. You're trying. And that's what matters.
So now you know why they're laughing, because you sound Japanese trying to sound Korean.
But when I was in Mexico with Javier, love Javier, there was one phrase I would say. He said, "When you say that phrase, you are from Mexico. You are a Mexican." And that phrase, give me a second. No, it's just vámonos.
Vámonos? Vámonos.
You gotta say it that way. And
Vámonos.
No, it was
like
vámonos, mija. Vámonos. You gotta say the mija in there as well. But yeah, Korean's difficult because it's so completely foreign. Like, we don't have any aspect of it here in the U.S.
Federico, be careful right now, because if you start saying stuff in Italian, you know what's going to happen, and it's going to be offensive.
Liz is going to try.
Well, now that we know Federico's here, let's do it.
I'll get my hand out. I'll get my Italian hand out.
Oh, well, all right. Let me say this. So I got lunch with Federico a number of times when I was off in Germany, of all places, and we went to an Italian restaurant, and he would say, and this pizza was good, but he goes, "This is not pizza. This is not real pizza." And he got kind of upset.
I really want to see Federico in like New York.
Or Chicago.
Well, deep dish doesn't count.
But that's the thing; they call it pizza, and that's like in the front to the religion of pizza.
Yeah, but it's deep dish is like.
I love dish.
I want to be able to fold it and shove it in my mouth.
All right, so
I don't want a fork.
My great grandparents on my dad's side are from Sicily and Naples. Mm-hmm. Couldn't speak.
Yes, you're right. Giorgione.
Oh,
yeah.
So my name was Giorgione, but they shortened it to George because it's English sounding.
Yeah.
Never mind.
Can you change it back?
Never mind. Never mind. They could not speak a lick of English.
Mm-hmm.
But yeah, we're the Georges. But I would go up to, they settled in Rochester, New York. I would go up to Rochester in the summertime from South Carolina. And we would get there, and my great-grandparents would just have, I would stay at my aunt and uncle's, but there would just be a spread of Chinese, not Chinese. Because we talked about Chinese. There'd be a spread. They're Italian. But there'd be Chinese.
Of Chinese food.
Italian, like meats and capicola and cheeses and stuff.
Italians got good meats.
It was so good.
We have the meats.
It was so good. And, but they really did. They talked a lot with their hands and all that. It was so good. And my granddad was... He would go around saying that he was 100% Italian, and then he found out that there was some Spanish in him, and he lost his shit. He refused to accept that.
Two fiery cultures in one.
I don't know. The Spanish culture is I'm going to say it, a little more fiery when they get up in their temper.
All right.
I don't know, but most of the mob is Italian.
But my hey. All right, Federico's watching.
In America.
But no, my granddad got real fiery about that. He was like fuck no.
He got a little racist, is what you mean. He got a little racist.
He was like, fuck no. I am 100% Italian. I will never accept this Spanish bullshit. And he went to his grave.
The great Spanish lie, the George family.
Look, I'm just all the generic whites. It's just English.
Oh yeah.
Some Swedish,
Scottish, German.
I got that as well.
German, Scottish, English, Swedish is
so if you look at,
where I'm at.
If you look at my mom's side of the family, it's like English, Scottish, Irish, all that kind of stuff, and they settled in what is called the Low Country of South Carolina. It's down kind of near the coast, and all that. But yeah, there was no Italian in them, but they had been. in South Carolina, I want to say 1600s, 1700s. It's been a while. It's been a minute. Low country, but on my dad's side, at least the Italian side of the family didn't come around 30s, 40s.
Oh, okay.
No, I'm sorry.
30s?
20s or 30s.
19?
Oh.
19.
Oh, that's late. Okay.
You're basically an immigrant.
Yeah, but you know, it's
my family's been here since the 1600s. Shoot.
Yeah, I did my ancestry. And I think, oh gosh, I think it might have been 1800s for mine in New York and then some in Virginia. I don't know if it was as early as in the 1700s. But there was some 16s that I found in England of some marriage documents where the lady ancestor was a spinster, but you know.
And she's like 26. Spinster!
Yeah, so this is my political statement of the episode. For all you fuckers that say go back home to everybody else, fuck you. You're all
America is a country of all immigration except for the Native Americans.
Like the world's richest man.
There's only one group of people.
The Native Americans.
There's only one group of people in this country that
they came over the Lamberts.
That were here.
Yeah.
Before these Europeans, they're Native Americans, and you know, they're like, you guys can go home. So,
but we put them in four corners.
Yeah.
That was a.
Yeah.
I know.
Yeah.
Oh,
that's true.
Yeah, you know. So, let's
go. That's amazing, Federico.
What does it say? What's he saying?
He says, if I track my ancestors, everyone is in a 100-kilometer range for centuries.
But
that's so fucking cool.
But all right, so on my mom's side of the family, though, that is true, except for it's a little bit further. It's about 100 miles. So
it's
that's
all
150 kilometers.
It's all in Carolina.
But yeah, and so my mom was born in Hemingway, South Carolina.
But for hundreds of years. Well, I guess if you go.
Yes. Like,
but
centuries.
He probably means like more than 100, because Italy is
my mom's side of family. Yes, centuries in South Carolina, low country South Carolina, Hemingway area. My mom branches out, quote unquote, goes up to Columbia, which is about 120 miles away. And she's basically been there. She did spend a little bit of time in, San Antonio and Phoenix, courtesy of the U.S. Air Force, but they went back to Columbia.
Yeah, but max 400 years in this country, whereas Federico could have family going back, because it's in Europe and it's not.
But the thing is that, typically we don't go far. We don't go far. But then you got me. I was like, fuck this. And I went all the way across the country. But, even you're still further away from where you were born.
Yeah, but it's like,
Brandon
I think the point is, though, that, his family is relegated to this area.
No, but you are. You're more than 100 kilometers. You're more than, 67 miles.
The house Federico lives in now is older than the USA, and I love that so much.
There's a great story. Somebody was talking to the German friend and goes, yeah, this house is built in the 1700s. It's so old. And the German guy goes, 1700s? My house is built in the 1400s. What are you talking about?
Oh my God.
I would do that. So I either like a really new house, kind of like what we have. It's a new house. Or like a really old house.
My God. When we first were looking into moving to
PBS
Utah,
series up in here.
We there was a house that we actually put a bid on that was a 1903 Edwardian house, and oh God. But just once the inspection came back and the upkeep, it wasn't going to be affordable for us or worth it, the money. But oh God, I love an old.
I was looking forward to that house actually.
If I could live in an old castle in Europe. Oh God.
Okay. We have 4 minutes before you guys have to go. We haven't talked about quantum yet, and we have 4 minutes to do so.
Quantum in 4 minutes.
Fancy physics, man. What do you want to talk about in 4 minutes about quantum?
Quantum, go. 4 minutes of quantum.
It's weird. Spooky. It's weird.
It's weird. Like, the whole...
Quarks, down quarks.
Quantum be wild.
Quantum be wild. The whole, because we talked about quantum entanglement, which is something that is just purely a quantum thing. Mm-hmm. Classical physics, Newtonian physics can't describe it in any kind of way.
Yeah, you need new physics. You need the newer physics.
Yeah, you need the newer physics.
Well, I guess you would call new physics whoever discovers this. Like, whoever discovers that grand unified theory, it's going to be that. It's not new physics anymore. It's Georgian physics. Georgiano physics.
Giorgione.
But you didn't do your hands.
I didn't do the hands, so it wasn't as effective. I apologize.
Sorry, Federico.
Only the hand motion makes the Italian language effective.
But I do have Italian in me, so me and Federico are brothers.
Meanwhile, Federico's like, fuck off.
Exactly. That's why I'm laughing, because he would be like, no, I do not claim Mike George at all in any kind of way.
Fucking Americans.
Except I am one of those progressive Americans, and so that is...
Which is still conservative in Europe.
Probably, but, I don't know, I could be pretty progressive.
Depends on which parts of Europe.
I really do have very socialist tendencies.
I've always been one of the most liberal people in any office I've ever been in, especially here in Utah.
Oh, God, yeah.
All right. Anyway, what were you saying?
Me?
Yeah, you were saying something about quantum.
You were supposed to be explaining
quantum.
I asked
you the question.
What was the question?
You got 2 minutes to talk about quantum.
Quantum
in 2
minutes.
You got 2 minutes.
And I said it'd be wild. It's
crazy. That's your take on it?
And then you started something.
So, this isn't what I was going to say, because what I was going to say, but I will at least say, in the early 2000s, my introduction to quantum, and one of my first introductions to, like, a deeper science in general, was, and you'll like this, Mike, The Elegant Universe by Brian Greene.
Yep,
and it was a PBS series. I think it was a 3 or 4 part PBS series. Mm-hmm. And I remember watching this with string theory, yes. And I remember watching and just being introduced to these insane theories and science I've never even considered would exist. And I'm like 12 years old watching this. So that was my introduction.
Yeah, so you have entanglement, you have tunneling,
and
which is crazy. So it's like, all right, I have this wall in front of me. It's a window, but there's a wall. But if I bang myself into the wall, enough times,
there's
eventually
a chance
I will tunnel through it.
Which I distinctly remember in that PBS series, Brian Greene leaning against the wall and saying, if I hit this wall, nothing's going to happen. But if I give me an infinite amount of time due to quantum physics, eventually I will pass through. And it was just the craziest thing. It's
mind-blowing. And quantum
Kool-Aid
physics.
Man does it every time.
What?
He doesn't pass through the wall.
I said the Kool-Aid Man does it every time.
Well, he kind of breaks the wall. But
that fourth wall, can't do that.
Quantum is just such a mind fuck when you get down to it. Mm-hmm. Like lasers. Lasers are purely a quantum thing.
Pop quiz. What does laser stand for?
Light.
And it ends in radiation. I don't know.
Oh, shit! I can't do it.
I did not know it was an initialism. An initialism.
I always get them confused.
Acronym. You always correct me every time I do.
I'm typically wrong when I do.
But there's also masers, which use muons.
Oh.
And then you have laser.
Those are the cat lasers because they're going mew mew.
Those are musers.
Yeah, but masers are muons, and so lasers use light. So photons, and
light as
so a maser instead of using photons uses muons.
You're right. Light amplification by stimulated emission of radiation.
I love how like you're right. Was that about muons?
Yeah. I just assume you're right in general.
Yeah, we all.
So do. I'm gonna interrupt you by saying, "Oh no, Mike's right."
I'm wrong 90% of the time.
Which is
maser
more accurate than we are.
But
then a maser is a muon. What the rest of lasers stand for? A muon. Amplification.
Stimulation.
Yeah. So I just say it with confidence. I'm like the
sure.
Proud Feet Hobbit.
When I say it with confidence, I sound Japanese apparently.
But you're speaking Korean, but you sound Japanese. That's great. All right, I think we should call it because we got family coming.
Take off.
We do.
I got work to go to.
We do have work.
Yeah, you need to sober up before you go to that work.
I have no food here.
Oh, well, it's all within walking distance. Come here, Leia.
Get some positrons in yourself, and you'll be fine.
Wait for it. Give me a second. Give me like 5 seconds. Give me some tachyons.
There you go. Some tachyons. And some duck. Apparently.
I do love some tachyons. Come on.
Oh God.
She's fine.
She's dog.
All right.
Don't. Okay.
All
right, everybody. Thank you for joining us on this episode of The Hangover. You can follow us on all the things at Drinking Cosmos on Twitter and Cosmos with Cosmos everywhere else. You can find The Hangovers only on YouTube, but you can check out our other full episodes and The Shot with Cosmos on Spotify, YouTube, wherever you get your podcasts. We'll see you next time for High in the Sky for May.
Cheers, everybody.
Bye, everybody.
We'll see you in 2 weeks. Bye.
All right.